Types of yield curve strategies. So when we think of yield curve strategies, we're only thinking about changes in interest rates. And therefore, we only use treasury bonds, because with treasury bonds, the only exposure you're going to get is to interest rates. And therefore, we avoid any exposure to things like credit and liquidity risk. So for example, if you look at a corporate bond, so the yield on a corporate bond is equal to the yield on a benchmark, which is usually treasury, plus a spread. So the treasury reflects exposure to interest rate risk, whereas the spread reflects exposure to credit and liquidity risk. The point of this framework is as follows. If you're using a corporate bond in order to exploit changes in the yield curve, well, you're not only getting exposure to interest rates, but you're also getting exposure to credit and liquidity. But I thought you were doing these strategies because you had an outlook on interest rates. So you see why we can't use corporate bonds in order to execute yield curve strategies? Because once again, this is really important, because when you're using corporate bonds, you're getting the whole package of risk exposures. But if you only want to construct a strategy around your outlook for interest rates, we use treasuries. Okay. So there it is, reinforcement, corporate bonds, you're exposed to interest rate risk, credit and liquidity, treasury, you're only exposed to interest rates. So working backwards, if I only have these expectations for interest rates, I'm going to use treasuries. So therefore, yield curve strategies structure a portfolio such that it profits from changes in the yield curve. Now we can categorize changes in yield curve into three groups. The first one, which is the major one, is change in the level of the yield curve. So we have two scenarios here, parallel up and parallel down. So starting with the blue yield curve, which is the initial one, you can see that there is a parallel shift up. In other words, across the entire maturity spectrum, the yields increase by the same amount. So this would be parallel up, or you can have parallel down. So again, starting from the blue yield curve, you can have yields across the entire maturity spectrum drop by the same amount, and therefore you get the resulting red line, which is the yield curve after the changes in yield. And what we're going to see in the subsequent modules is what strategies would we use under each of these expectations. So in other words, when you think that the yields are going to experience a parallel shift up, what do? How do we profit from this? At the same time, if you think the yields are going to drop in a parallel fashion, what strategies can we use in order to profit from that? The next group of yield curve changes is change in the slope of the yield curve. So there's two scenarios here. When the slope is changing, it could either be getting steeper or it could be getting flatter. So again, starting from the blue line, which is the original yield curve. And the other thing I'll point out is the following. Unless you're told otherwise, always start off with an upward sloping yield curve. So even in this original example, see how the blue line is always upward sloping? Because in reality, that's the general case. So start off with an upward sloping yield curve. And then if they tell you it's steepening, so what's the only way the yield curve can go here? You could see that the red line is getting steeper. And that would mean that the short end of the yield curve is dropping more than the long end of the yield curve. On the other hand, if it's flattening, once again, starting from the blue line, which is the original yield curve, you could see that the red line is flatter, right? And how did that come about? Well, the short-term yields increased more than the long-term yields. Now, the slope of the yield curve is measured by looking at the spread, or the difference between the 30-year yield and the 2-year yield, okay? So again, we just look at, so if I'm looking at this example, I would look at the 30-year yield here, and I would subtract the 2-year yield here, and the difference between the two is the gap in between. Now, of course, the wider the gap, so as this spread or gap increases, it would indicate that the slope is getting steeper. On the other hand, if it's flatter, so looking at this scenario here, where the yield curve is getting flatter, you could see that the difference between the 30-year yield and the 2-year yield will not be as great, okay? Now, in the event that the spread is negative, it would indicate that the 30-year yield is less than the 2-year yield. So in this scenario, you'd get a negative spread. Then it would mean that the yield curve is inverted, because if the short-term yield is greater than the long-term yield, then the yield curve would be shaped like this, okay? Now, the third category for yield curve change is a change in its curvature. So two scenarios, the yield curve can become either more curved or less curved. So again, start with an upward sloping yield curve as represented by the blue line here. And so how would the yield curve become more curved? So this is one scenario here. You could see how the red line is more curved. So what happened here? Well, you could see that the short end and the long end of the yield curve dropped more than the middle, right? On the other hand, less curved, let's see here, starting from the blue line, which is the original yield curve, you could see how the red line is less curved, right? So what happened there? Well, you know, the short end and the long end increased in yield more than the middle. Now, to measure curvature, we look at what's called the butterfly spread right there. And the way we find that is by taking 2 times the yield to maturity of the middle. So right here, that's 2 times. And we subtract the sum of the short-term yield and the long-term yield. Why the 2 times? Well, aren't you kind of ganging up on the middle, right? Because you're sort of putting the short end and the long end together. By the way, these make up the wings, right? Because they're at, you know, either end. So you got 2 components on the wings. So to think of it this way, to sort of even the playing field, we look at 2 times the middle. So 2 components representing 2 wings, and 2 components representing the middle, which represents the body. And that's exactly the analogy I'm using here. So 2 times the middle, that's your body, and the short end and the long end, so on either side, those are the wings. And that, ladies and gentlemen, is how they came up with the term butterfly spread, right? So big thick mass in the middle, so 2 times the body, that's the big mass in the middle, and then you've got the 2 lighter wings at either end, okay? Now, an increase in butterfly spread, well, it's just algebra here, right? So an increase in butterfly spread indicates that either the middle yield is increasing more, or these wings are decreasing. Or alternatively, in this case, the middle is decreasing less. So if this component is decreasing less, you could see that right here, but the wings are actually decreasing more, then that too would cause the spread to increase. So just looking at this and plugging the changes in yield from that diagram into this algebraic framework, you could see that the spread would increase. And of course, if the spread is increasing, it would indicate that the body, the middle, is actually rising above or is higher relative to the wings, and therefore the yield curve is becoming more curved. Now, tip, these 3 sources of change in the yield curve can occur simultaneously, and they are uncorrelated. In other words, there's no relation between change in level, change in slope, and change in curvature. So over here, I show a demonstration of how you can have all these categories of changes occurring simultaneously. So let's build this from the ground up. And here we are. So initially, we have yield curve 0 represented by the blue line. And then let's say by the end of the year, the yield curve is represented by the red line. Now watch how we can break down this total change in yield curve into these different categories, i.e. change in level, change in slope, and change in curvature. and there it is, right? So therefore, from the blue line to the purple line, we can sort of consider that as the parallel up change in the yield curve. And then from the purple line to the green line, that would represent the change in the slope of the yield curve. And you could see that the green line is becoming flatter. And then the residual change in the yield curve can be attributed to curvature. And the point that the author is making, and that this diagram is trying to demonstrate, is you can have all these different drivers behind yield curve change occurring at the same time, and they're unrelated. So for example, in this scenario, I had parallel up while the slope was flattening and it was becoming more curved. But we could have just as easily had parallel shift down while the slope was getting flatter and the curve was becoming more curved. The point is, you can mix and match any of these because here's the thing. Interest rates are kind of random. So it's not like we're going to make interest rates fit the model. Instead, what we do is we make this framework describe what's actually happening to interest rates.